Lesson 1, Experimental Probability. So experimental probability is when you have probability that you are actually doing. So we have two types, experimental and theoretical. So theoretical is how many ways things would happen in the perfect universe where mathematically it always happens. So for instance, my example would be if I was to flip a coin. If I flip a coin 10 times, I should get 5 heads and 5 tails, theoretically. But if I'm actually going to pick up a coin right now and flip it 10 times, I might not get 5 of each. That's called experimental probability. That's what actually happens. Now, the greater your sample size, the more things you have, the closer it's going to get to that theoretical probability, but it's not a perfect world, so it might not always happen. So we still express things as probabilities and we use them to guide us, but it's not always necessarily what's perfectly there. So we have 4 ways that we can show our probability. We can show it as a percentage, like 50% of the time. Let's keep going with this heads and tails example. We could do it as a fraction, so that would be the same as 50 out of 100. Percentages are always out of 100. Or, as we know, that's the same as 1 over 2. It can be a decimal, so 0.5. And it also could be a statement, so 5 out of 10 times would be an example for that. You could do 50 out of 100 times, 1 out of 2 times, lots of statements. We often take a statement in the form of a word problem. So let's do a word problem. So we have Shelley works at a store and it sells light bulbs. She finds that the current shipment has a high number of defective light bulbs. She has to decide how to test how probable it is that light bulbs in the assembly line are defective. So she sees that out of 265 tested, 2 were defective. So we're going to express this probability in all of them. We don't have to do it as a statement because the statement is the word problem. But to make it as a fraction, we want to say the number of ways it happens, so defective, over how many ways in total. So 265 is our total. So the top number is always what you want to happen, or what you don't want to happen in this case, and the bottom is the total. You don't have to simplify it, that's good enough for me. If we want to change it to a decimal, we're just going to divide those two numbers, and you should get 0.0075. And if we wanted to change that into a percentage, you would times it by 100 to get 0.75%. So there's not a big percent chance of these light bulbs being defective. Part B says, in a shipment of 5,000, how many light bulbs are likely to be defective? So we know that there's defective and there's the total. We know that in 2 out of 265 we can find defective and the total. We want to know how many would be defective, so X, out of a shipment of 5,000. This is something you should know how to solve now. It is called proportional reasoning. You've done this lots. So to solve it, we're going to cross multiply and divide. So we're going to do 5,000 times 2 divided by 265. And the number that you would get is 37.7. Oops. So in the shipment of 5,000 light bulbs, 37, roughly 38 are going to be defective. Does that mean that there's necessarily going to be exactly 38 defective? Probably not. But using this statistic, you can find a reasonable estimate of how many would be defective.